Good morning, everyone. Today we'll be talking about DNS tunneling and how you can use HTTP commands through DNS queries and use it as an attack vector. The presentation is formatted in a way where we talk about DNS tunneling and few scenarios where DNS tunnelings are used and how it can be used as an attack vector, the demonstration of the attack itself, and few advanced concepts and exploits of the same, along with the mitigations and defense mechanisms. So what is DNS and DNS tunneling? DNS is basically a system which translates human readable domain names into IP addresses. This enables users to access websites without really memorizing the whole complicated numeric digits, that's your IP address, of every other URL that you're trying to access. So how it works is when a client requests for a URL, it first checks in its local cache if it has cached any of the DNS records. If not, it goes to the router's cache, even if it's not present there, and it reaches to the recursive resolver, say your Google's recursive resolver or Cloudflare's recursive resolver, which then goes to your root, which tells you which top level domain basically has the DNS record of the URL that you're requesting. Let's say you're requesting for example.com. It navigates you to the .com, top level domain name server, and the .com server leads you to the final authoritative server, that is example.com, which has the final DNS record that the client is requesting. So how DNS tunneling works is basically an attacker use command and control channel through the DNS query that is run by the DNS servers, right? So instead of requesting for an IP address, what the attacker does is it passes smaller commands as TXT records through the DNS queries that the client is requesting for. So since the TXT record has a particular size, that is 250 bytes, you cannot really perform or transfer large packets of data. You can only do things slowly, chunk by chunk, to the allocated memory that a TXT record can hold. So there are also legitimate use cases for this. Let's say you're an antivirus provider who wants to update, the version, or push some kind of over the air updates for these antiviruses. You can basically run without the users updating their firmware, etc. You can also expose your local machine that is inside your LAN to an outside world by linking a subdomain's A record with the machine's IP address. That way, you can basically access a local host URL through the subdomain that is configured to access that particular machine. So how this attack can be used in scenarios is, say you're in a cafe and they have this captive portal that basically which requires your username, passwords, and few other details for you to access the internet in that particular cafe. And say you don't really want to give your personal information out. What you can do is, since the firewall has blocked HTTP requests to their internet, you can pass in DNS queries, which is not blocked by these firewalls, so that you can bypass your gateways and get the HTML response through your DNS queries. So this way, you're not just getting the IP address, but you're also making your DNS server act as a proxy server for your particular request that you're trying to access. So how does this work? Is basically as an attacker, you need to basically hold control of the website the client is requesting for. Um, or you can basically use that particular domain as a proxy server, which basically gets all your access a proxy to make all the HTTP requests on behalf of the client. And now that particular authoritative server is acting as a middleman between you and the data that you're requesting for. So this domain's name server points to the attacker server, and then whichever client is trying to access, you can take control over through the malware that you're trying to infiltrate through the DNS records. So, like we spoke, since the firewalls in their system only blocks HTTP requests and not DNS requests, you gain access to any of the data that's behind the firewalls. So, looking at the attack itself in action. There are two kinds of attacks. One is the script-based attacks, in which we've used uh, a Python script, one for the client and one for the server. And this was performed completely inside the LAN so that nobody else system were used as a guinea pig. And we use DNS lib for making all the DNS queries, base64 to encode the data through your TXT records, and the request library to basically make the HTTP requests on behalf of the client.
Base attack. We are basically using a Python script for both the server and the client. And we create a resolver class, which is inherited from the DNS lib library. And we override the resolve function so that we can perform the tunneling based on the requirements that we have. So the resolver basically takes in the DNS request from the client. And then what we do is we split the subdomain from the host name of the URL that the client has sent. And since the client name is encoded, so the host name is encoded in base64, we decode it first and then make a HTTP request on behalf of the client. And that is stored in the response. So this HTML content, since it's pretty huge, what we do is we break it down into multiple chunks. So the TXT record of the DNS class can only hold up to 255 bytes. So since the HTML text is pretty large, we break down the chunks into smaller packets, that is 250 bytes, and add multiple TXT records to the DNS response that the server sends. So the HTML text is first encoded into base64, and then multiple chunks are created in the size of 255 bytes, and then sent as a response. And this response is in the format of a resource record, which basically contains the type of the record and also the data chunk that we're sending. And then once we have the resolver, we create a DNS server, which takes the resolver as the parameter. And we mention the port, which is 53. 53 is the default port in which the client sends all the DNS requests to any of the servers. And 0.0.0 basically mentions that we need to listen on all the interfaces, that is including the loopback, wireless, Ethernet, etc. And we enable TCP mode for the communication. And once we have the server running, we go to the client side of things. Here we have a very simple function which takes in the URL as the parameter. And we change this URL, we encode this URL to base64. And we ask our resolver, that is the server, to basically give us the TXT record. So we create a query which asks our DNS server to basically return the TXT record, right? And we point our resolver to the local host address. And since we're not running the DNS server in any other machine, we point it to the loopback address. And once the query is resolved by our server, we get multiple TXT records as the response. So basically, our server is now returning HTML content in forms of TXT records through the DNS query that we requested. And the URL is also something that is sent by the client through the TXT record in the DNS query that we've built. And the rest of the code is basically breaking down of the TXT record, decoding it back to UTF-8 string from base64, and reconstructing the whole HTML response, right? And for the sake of the demonstration, we're just creating a temporary HTML file and storing the HTML content there so that we can see what the response is returned from the DNS server that we created. So now let's say we update the path and start our server and say we request for example.com, right? You'll see that the server has requested for multiple the server has responded with multiple TXT records, and the whole HTML response is here. And we can see that the same has been opened on the browser. And if you see the actual example.com, it's pretty similar to what has been opened on the file as well.
So that was what the script-based attack. And the same can also be done with other tools like DNSCat or Iodine. So it kind of encapsulates or abstracts all of your logic, and it not just lets you perform HTTP requests, but also say run shell commands or pass any kind of data through your TXT records. And it kind of gives you more flexibility on the kind of control you want on the client machine, right? So for the second one, we've used DNS cat, and this was done with some kind of you know uh, monitored network, so that you don't really infiltrate into somebody else's network.
So we have DNS Cat2, which is a wrapper around the whole DNS tunneling library. This not just lets you run or pass HTTP commands over DNS, but also lets you run other, say, shell-based scripts or any kind of data that can be passed through the TXT record that we spoke about earlier. Now, let's say I'm running the server, and my friend on his machine also has the same library running. And he now has established a connection to my particular domain, that is tunnel.runag.xyz. What I've done in the CDN is basically configured an A record that points the subdomain tunnel to the IP address of my local machine. So if you right now see the IP address, the IPv4 address, it is basically 10.0.0.97. So when my friend connects to tunnel.runag.xyz, and since I'm the authoritative admin of this particular domain name, I have successfully established a session with my friend on his machine, and I basically can control almost everything on his machine. So if you look at all the commands that you can execute, there's a list of things. Let's say we decide to open up a new shell command. Say a new shell is created, and you can see that it's basically pointing to his machine. And mine, the name of my machine is basically Pranit, and the username here that you can see is Sushant, right? Now let's say I switch to that particular session. And you can see that we almost have all the drivers, all the files are basically there in this particular path on his machine. And I can decide to like basically have control over anything that is there on his laptop.
Right. So the defense mechanism for such attacks is basically you monitor all the traffic that is going through your local recursive server, or the authoritative server for that matter. In case they have, say, a large number of data through their TXT records, and they're sending multiple TXT records through the same DNS query, you can kind of mark it as suspicious and then trying to add a blacklist. So this blacklist is basically known malicious host names, where you know for a fact they are trying to perform such kind of attacks. And say you can block such DNS requests by having a blacklist and making sure traffic is not redirected, or your DNS server does not respond to such queries. Right. So concluding, DNS tunneling can be used to bypass such internet restrictions and controls in places where you don't really want to give access to other people, say access to in terms of your personal information or other details, and use DNS tunneling to request any kind of data that you want. So the DNSSEC area mostly controls the cryptographic side of things and basically handles the security aspects of how the certificates are handled and how root level domains or the hierarchy is basically controlled at each level. But there is very less security measures taken on such kind of attacks, and there could be better defense mechanisms created. Thank you. You can also access the code in the link provided.